Okay, so this is going to be another arc length problem, and I think that this one's going to be a bit more interesting because it actually has a natural log in it. So we're going to evaluate this one from 1 to 2, from x equals 1 to 2. And this is the region of the curve that we're interested in. Notice it actually has a very short vertical change, so this should be, kind of close to 2, or kind of close to 1, something around that range. A very short arc length. So, I want to find f prime of x, which is going to be equal to 1 over x minus 1/4 x. So, we remember our formula for arc length is the length is equal to integral from a to b, square root 1 plus f prime of x squared dx. So this is our formula. Now we just get to plug stuff in. So the length is going to be equal to the integral from, and I said I was going to do this from 1 to 2, of the square root 1 plus, now we need f prime of x, which will be 1 over x, which would be x to the minus 1, minus 1/4 x to the first squared dx. So, now this is going to take a little bit. The length is equal to integral from 1 to 2. I'm going to distribute, or square this term. 1 plus x to the minus 2 minus 1/2, and erase this, plus 1/16 x squared dx. So that's it, squared out, expanded. And now I'm going to combine like terms. So 1/16 x squared plus x to the minus 2 plus 1/2 is equal to, whoops, not is equal to, times dx. There we go. So, continue. L is equal to integral from 1 to 2. Now, I continue to like to break this up into a numerator and denominator. I find it just easier to work with. So, what's our common denominator going to be? It's going to be 16x squared. So, I need to multiply above and below over here by x squared. So this will be x to the 4th plus 16 plus 8x squared all over 16x squared dx. So now we have the length is going to be equal to 1, 2, square root of, well, the bottom is easy, that's just 4x. The top is going to be the square root of x. Did I do this wrong? No, it's right. So x squared plus 4 squared dx. So now this the square root and the square in here cancel each other out. The length is going to be equal to the integral from 1 to 2 x squared plus 4 over 4x dx. And I'm just going to break this up in one line. 1 to 2, 1/4 x plus x to the minus 1 dx. So now we can integrate. This is an easy integral to do. It's just the anti-power rule. So 1/4 times x squared over 2 plus the integral of x to the minus 1 is natural log of the absolute value of x. And this whole thing is evaluated from 1 to 2. Now, we can see here the length is going to be 1/8. Well, I'll do this. I'll simplify it on this line. 1/8 x squared plus, and since both of these are positive, we can ignore the absolute value in this case, ln x. So, plugging in 1/8 times 4 plus the natural log of 2 minus, then you evaluate the integral at 1. So we have 1/8 plus the natural log of 1. And this length would be 1/2 plus the natural log of 2 minus 1/8, because this is just 0, which should actually be 3/8 plus the natural log of 2. And if we actually punch that into a calculator, we get natural log, we get 1.06. Which makes sense because it's a very, very little vertical change, and just a unit change in the x direction. So it should be close to 1 anyway. So that is the solution here.